Rational exponents, another word for rational. Whenever we see things like this, we're talking about fractions. Okay? Rational exponents. We're talking about fractional exponents here. Okay? Here are 3 examples. Okay? And essentially what fractional exponents mean is that we're dealing with radicals. Okay? And the form looks something like this. So if I have a number raised to a fractional power, there's a relationship between that denominator's power and the numerator's power. So the denominator corresponds to the index. So notice here, square root of 25, that's 25 to the 1/2. Cube root of 27, 27 to the 1/3. The denominator is the index. Now the top number, the numerator, is the power on that base, or the radicand. In this case, they're all raised to the first power. We just don't write it. So if you wanted to write it just to see that correspondence, that's what it would look like. Okay, so that's where those ones are, but we just don't have to write them in. So when you see an exponent that's a fraction, it really means that the denominator is the index of a radical, the numerator is the power on the base, or in this case, the power on the radicand. So it's another form of radicals. You just have to be on your toes so you know what exactly you're trying to do. This would be known as radical form. This would be known as rational exponent form. Okay, they mean the same thing though. So let's go ahead and do that. Right? X to the 1/6 in radical form. Go. How would we say that though? What is that?
The 6th root.
6th root of x. Okay, I don't need to put the x to the first. No big deal. How many have that? 6th root of x. Okay. Now, notice the difference. This one doesn't say write in radical form. It says evaluate. Evaluate means find the answer. Figure out what this equals. Okay. In order to do this, one of the mistakes that you'll make is you'll try to somehow multiply these together, something like that. That has nothing to do with it. When you have that rational exponent, you have to rewrite it as a radical. So do that. Now I know I showed on the first page what's up top here. You can also slide the x out, or the numerator out, and do the radical part first. So you can put the x in the power inside the radical, or you can put it on the outside. And I'll be honest with you, most of the time, if you do it this way, your numbers will be smaller, and you can do it without a calculator. Okay? However, if you want to do it this way, that means you're taking things to a power first before you're taking the radical. And I'm going to show you both ways for this problem, but keep working through that one. So here's what each one would look like. The top one, so now you're going to have to square 8 first, and that's the cube root of 64, which maybe you know. But in this case, I could take the cube root of 8, which you better know, and then square it, right? Because what is this? What's the cube root of 8? 2. 2 squared is, okay? So either way, I end up with the same answer, but I feel like when you try to make your numbers smaller first, it makes working through them easier. Now, if you know the cube root of 64 is 4 off the top of your head, great.
We use that calculator?
Of course you can, but at the same time, my preference is for you to go quicker and be more efficient, and that means not using a calculator. But either one is fine. I'm not telling you which one you have to use. I will tell you that most of the time, though, this one is going to make your life a little bit easier. Okay? Any questions on that? Do that one. So again, got a couple different options. If you're going this route, then you're taking 16 to the 3rd first, and your numbers are going to be pretty big. And I don't know about you, but I do not know what the 4th root of 4096 is. Okay? But over here, 4th root of 16 is easy enough. Obviously, either way, I get 8. Okay? I would prefer, I think you would prefer doing it this way too. But either way is fine. If you're just going to be a calcaholic and go crazy with your calculator, you can do it that way too. All right? How many had that? All right, good. let's make it a little tougher. Okay, so now we can look at our power rules and our properties, and we can use them the same way, even if the exponents are fractions. So when the bases are the same and you're multiplying, what do you do with the powers? Add them. Do this. So what is 2/7 plus 4/7? 6/7. Now, one of the things that I would tell you is when it says simplifying, it doesn't tell you any more information like that. It goes back to some of the stuff we talked about before with fractions and decimals and that kind of thing. Stay consistent. The problem started with rational exponents. Don't make your final answer have radicals in it. Your final answer should also have rational exponents in it. Okay? You can work through it sometimes with radicals and convert it back, and I'm going to show you an example like that here in a little bit, but just stay consistent with whatever the problem starts with. Okay. Another problem where I have power to a power. What do you do with the powers when it's power to a power? Multiply. Do that one. What is negative 2/5 times 1/2? Huh? Almost. Negative 1/5. What is 1/3 times 1/2? 1/6. So here's where I'm at right now. Okay? As we know, you can't have negative exponents. So what has to happen with that x to the negative 1/5? It's going to have to go to the bottom. So, now what's the problem? What does x to the 1/5 really mean? 5th root of x, which means I have what in the denominator? A radical in the denominator. That's bad. So we have to rationalize. But when we rationalize denominators with fractional exponents, we can do it a little bit differently. Okay? It's similar to what we did in 6.5, but we can do it with the actual power rules that we know. Okay? If this power was a 1 instead of a 1/5, x to the first, it would just be a plain x. Alright? So what would I have to multiply x to the 1/5 by to get an answer of? So I'm going to multiply this by something. And I want my answer to be x to the first. X to the 5th? So, is x to the 1/5 times x to the 5th, does that equal x to the first? What do we do when we're multiplying, and what do we do with the powers? You add them. So 1/5 plus 5 is 1? I'm afraid not. That is incorrect. What plus 1/5 gives me 1? 4/5. Okay? What I really need to do is multiply top and bottom by x to the 4/5. Because again, keep in mind your power rules. When I'm multiplying, you add the powers. When it's power to a power like this original problem was, then I multiply the powers. Okay. Now I can't do anything with the x to the 4/5 times y to the 1/6. They're different bases. So I can't add powers or anything like that. Bottom just gives me x. And notice I put the x term in front. Now it's rationalized. I don't have a radical in the denominator. And I didn't have to turn anything into a radical in order to work through it. Okay. We can use our understanding of the power rules to change this radical to something without a radical. So that is my final answer. Are there any questions on that problem? We can work through them that way. Okay, the next example is a little tricky too. But you're going to have some problems like that. And you're going to have some problems like this. Now, oftentimes, when I have radicals with a different index, using rational exponents allows me to put them together. Because, as you know, I can't just say the square root of 8 or something like that. I can't divide the indices. When the index for each radical is different, you can't combine together. However, one of the things that we can do is look for a way to use fractional exponents if we have the same base. Now, usually what you want to do in a situation like this, you want to see if I can write the bigger number in terms of the smaller number using powers. Okay? So the question is, can I rewrite 16 as 2 to some power? What would it be? 2 to the 4th power is 16. Here's what that does for us. Okay? If I convert the top and the bottom into rational exponents, what would that give me for the top? If I turn this into a rational exponent, what would it be? 2 to the 4/6, which reduces to 2 to the 2/3. Okay? How would I write this as a fractional exponent? 2 to the 1/3. Here's what this allows me to do. Okay? When I'm dividing and I have the same base, what do you do with the powers? Subtract. So I really have 2 to the 4/6 minus 1/3. Well, you already told me what 2 to the 4/6 is reduced, right? That's 2/3. So all of this equals 2 to the 1/3. Can I leave my answer like that? Am I done?
No, because it didn't start off that way.
I didn't start off with fractional exponents. I started off with radicals. So I need to convert that into a radical. So what is that radical?
The cube root of 2.
Cube root of 2. And that's my answer. Okay? So, when you see a radical over a radical, don't immediately think that you have to rationalize, especially because the index for each radical is different. See if you can rewrite the radicands using the same base. Because if you can do that, then the idea that the indices are different may not be of consequence. Because I can then employ my power rules when the bases are the same. In other words, turn the radicands into the same number, and I can convert it to thinking about it as powers instead of radicals. And then just at the end, I need to shift it back. Okay? That's 6/6. You're gonna have a little bit of work to do today. Tomorrow with the block day, we're gonna go over 6/7, which is not bad. And then we'll also do some more of 6/6. Okay? So even though 6/6 is 2 days, it's lumped in with part of 6/7. Okay? Questions about anything? So really all this is about is combining all the power rules that you already know, a different notation for radicals, and that's really the new stuff. Okay?